Hey guys, this lesson is April 22nd. Today we will be reviewing for test number 9. Okay, yesterday you should have completed the quiz, and today we're looking at just spending some time in reviewing for test number 9. Now, test number 9 is a quarter exam, meaning that it has a lot more material on it than some of the other ones. So we're going to go back into the book and study some of these sections, go over each question by question, and make sure we give examples of all this so you know what to expect. So we're going to start here on our quarter exam. This is over chapters number 7 through 9. Okay, so all of the information will be found between those chapters. The first 3 questions are multiple choice, okay? The first question that they ask you on the multiple choice is, what is the equation form of a pure quadratic? Okay, what is the equation form of a pure quadratic? Now, you say, I remember the term, but I don't remember what exactly it means. Go back to page number 311, okay? And they give you a description of, or they show you what a pure quadratic form of an equation would look like, okay? So we know our typical equation. Let my whiteboard pull up here. Our standard form of an equation would be ax squared plus bx plus c equals 0, right? So it's looking for the test is asking for the pure quadratic form of the equation. Okay, if you go back to page number 13, they'll show you the actual written form of the pure quadratic. This is not it. Okay, this is the standard form of an equation. They want the pure quadratic form. So take some time, turn back to page 311, and find out what the pure quadratic form of the equation is. Okay, question number 2 is asking what the quadratic formula is. Okay, so make sure that you have your quadratic formula memorized. Okay, we know that the quadratic formula is x equals negative b plus or minus the square root of b minus 4 times a over 2 times a. Okay, that is the quadratic formula. All right, so they'll give you multiple choice on that, but know what your quadratic formula is because it's going to be used here anyway. So that's number 2. Question number 3, which of the following is not a perfect square trinomial? What is a perfect square trinomial? Okay, so when I am factoring a trinomial and I want it to be a perfect square, I'm going to end up with the answer x plus or minus a number, and this is squared. Okay, so this is what my answer would be from a perfect square trinomial factored. Okay, meaning what is the perfect square trinomial that gives me an answer like this? So they'll give you multiple choice here that you will be able to choose from. Okay, so I'm going to look at these different trinomials that they'll give me that look something like this. Okay, and what I'm going to do is I'm going to say, okay, if I were to factor this out, okay, would I end up with 2 perfect square trinomials? In other words, could I write my 2 factors in this form right here? Okay, if you can, then that is a perfect square trinomial. Okay, if there will be one multiple choice on here that you will not be able to write in that perfect square form. Okay, so you'll have to factor all those out and find the one that does not factor into a perfect square, and that will be your answer for that. Okay, so those are the first 3 questions. Those are multiple choice. Then we get in the next section of factoring. Okay, now we talked about factoring. Let's see, I didn't put the lesson plan down, but there were several different situations of factorings that we dealt with back in the book. Again, this will be between chapters number 7 and 9, so you can go back and review them. But I wanted to take some time and just show you examples of these that will be similar to the ones that are on the test. They're not the ones that are on the test, okay? But they'll be similar to them. And we can see the different types of factoring that we will come across here on the test. Okay, so let's take a look at these. The first one we'll come across will look something like this. Okay, it won't be exactly like this, but it will be similar to one like this. Okay, so I know that my first step in factoring is to examine each term and determine if there's a common factor that I can pull out of all of my terms. Okay, so in this case, I look immediately to my x's and I see that I've got 3 x's here and 2 x's here, which means I can pull out an x squared. Okay, and if I pull out an x squared, then I have here 1x left over and here no x's. Okay, so I can pull out an x. Then I look at my numerical coefficients and I say, are there factors that I can pull out that are common in both of those? Well, we know that 4 is a combination of 2 times 2, and 6 is a combination of 2 times 3. Oops, excuse me. 2 times 3. So we see a common factor of 2 that we can pull out of here. So I'm going to pull 2 out, okay? So I'm pulling these 2 out of my factors for 4 and 6, okay? So what does that give me? All right, what does that give me left? Let me move this over a little bit. Okay, so what is left after I pull out 2x squared out of all of these? Well, I have a 2 left over, and I have 1x left over here. And then I have a 3 left over because I pull out my 2. I have 3 left over, and I have no x's left over, okay? So I get this right here. Now from here, typically I would look at this and say, okay, can this be factored out anymore? But since this cannot be factored out anymore, then my answer literally is 2x squared times 2x minus 3. So this is the answer that I would write on the line. Okay, so number 4 on your test will be similar to this case right here. All right, number 5. Number 5 on our exam. Hold on just a moment here. Okay, so let's look then at number 5 on the test. Okay, we're going to have a similar question to this here. We have x squared plus 2xy minus 3y squared. And again, this is not what's on the test, but something that's similar to it so we can see how we're going to break these down, okay? Now, we're talking about factoring here, okay? There's a couple of things that play into my factoring. Number 1, do I have a numerical coefficient here? If I don't, then my x squared is basically just divided 1x into both parentheses, okay? And then I have my numerical coefficient for my last term, which will be broken up into these two binomials, okay? I also have this y squared, meaning I'm going to have a y here and a y here, okay? We're going to break that y squared up. So now I look at my -3 and I want to divide this, factor this out and divide those terms here. Well, there's not really many options here. We have 3 and 1, so it can either be a +3 and a -1 or a -3 and a +1, okay? Now, after figuring out those different signs, okay, by trial and error there, we find that we get x plus 3y times x minus 1y. Now, typically, I wouldn't have to write this one, but I'm just writing it out so that you can see what I mean. Okay, so this particular type of factoring, I'm just factoring into 2 sets of parentheses. This is not an equation that we're solving, meaning we do not need to solve for x in these equations. We just simply are factoring, okay? So my answer then would be x plus 3y times x minus 1y, or y, okay? And that would be the answer that I would write on my line. Now remember that this plus sign is going to give us an indication of what our signs inside of our parentheses will be, okay? So keep that in mind as you're factoring, but we're just taking that last term, finding the factors, the possible factors, and then multiplying out by trial and error to find which one, when I multiply this, okay, gives me my original equation, okay, or original trinomial, all right, and then that will tell me whether or not which numbers need to go in there, and so on and so forth. Okay, so number 5 on the test is just going to be basic factoring. Okay, we're going to get a set of two parentheses. We just got to find out what those factors are inside the parentheses. Okay, number 6. All right, let's look at number 6 on the test. Number 6 is going to be similar to this. Okay, and again, we've got just factoring going on here, okay? So first of all, can I factor anything completely out? Well, that's not an option here, okay? So I go to my next step of breaking these down into parentheses, okay? If it's a perfect squared trinomial, I only need one parenthesis. That would be written like this, okay? But in this case, we're not going to have a perfect squared trinomial, and I know that because of my 3. So I have to find different ways to do this. Now remember, I've got a numerical coefficient here, okay? So I also have to look at the factors of 5 to determine what my factors could be in these parentheses. Now we know that because 5 only has the factors of 5 and 1, we know one parenthesis will have 5a and one parenthesis will have 1a, okay? And then we break down our factors of 3, which we know the factors of 3 are 1 and 3, okay? So we find 1 and 3, okay? And we may have to move these around, okay, to test different things, different options, okay? But we know that we have a 5 and a 1 and a 3 and a 1 as our factors. And because they're both positive, then we know that they're both positive binomials, okay? So that is what number 6 will look like on your exam, okay? Number 7 is going to be similar. Hold on just a moment here. Okay, sorry about that. My kids are not cooperating today, but okay, so that was number 6 on our test. Let's look at number 7. Now, I don't have an example for number 7 because number 7 is similar to number 4, okay? The only difference here is we are factoring out in number 7 first, finding what common factor we can pull out of each term, and then you get a simple trinomial, okay? Let's say it looks something like this. I don't know, 2m squared plus 8m plus 2, okay? Let's say it looks something like that, okay? This is after we factored out 3 out of each of these terms, okay? So we get basically our number that has factored out, and then we also get a trinomial. Then we're going to take this trinomial and factor this out, okay? So then I would have 3 times this times this. So my answer would be in this format after I have found the factors for this, okay? So it would look something like this, plus, and then I'd have to find my options for this, and so on and so forth. Anyway, I made up these numbers so it doesn't factor out properly, but you get the idea, okay? So it's basically first, it's similar to number 4 in that we're factoring out first, and then we're taking what's left, factoring that into 2 parentheses, and then my answer is those 2 parentheses, including what I factored out here at the beginning. So this is what my answer would look like. So that is number 7. Okay, so all of those are dealing with factoring, okay? All of those we're dealing with factoring. So we are going to need to go back and review some of our factoring sections between Chapter 7 and Chapters 9, okay, to prepare for that particular part. All right, the next section is modified true and false questions, okay? Modified true and false questions. I'm going to give them to you, and I'm not going to give them to you in order, but you will need to find the answers for them and know what they are for the test, okay? So the first one I'm going to give you, let's call this number 8, okay? The Pythagorean theorem is, and this is the underlined part, okay? So this is a true and false question. Is this the correct Pythagorean theorem? If it is not, on the line you'll be writing the correct Pythagorean theorem. If it is the correct Pythagorean theorem, then you just simply write true on the line and move forward. Number 9. The variable in the linear term of a quadratic trinomial is always raised to the first power. Okay, is that true or false? Now remember that linear term is that middle term when we're in standard form. It's the term, it would be, it would be your middle term, okay? If I had, let's say we've got this. Okay, so this would be my linear term. Okay, the variable in the linear term of the quadratic trinomial is always raised to the first power. Is that a true or false question? Okay, number 10. Okay, number 10 is the zero factor property allows for each factor of a factored quadratic equation to be set equal to 0. Okay, the zero factor property allows for each factor of a factored quadratic equation to be set to equal 0. Is that true or false? So go back into your book. Remember, this is the lesson that Pastor Todd taught you while I was gone. Okay, so go back into your book and find that, whether that is true or false. Okay, the last question here, and let me clear my, this will be question number 11. Again, true or false. Okay, according to the fundamental theorem of arithmetic, every composite number can be written as a sum of prime numbers. Okay, sum is your underlined word. Okay, so go back in your book and look that up, talking about composite numbers in the basic theorem of arithmetic, okay, to find out what that answer is there. Okay, so those are your modified true and false questions. Okay, again, those are numbers 8 through 11 there. Take some time and find those and get those, get the proper answers ready for those. Okay, the next section is simplification of radical expressions. Now, if you remember, we talked about the different areas of radical expressions. We talked about adding them, subtracting them, multiplying them, denominating them, dividing them. What do we do when we get one of those in the denominator of a fraction? What do we do with that? What do we do when we get radicals with different indexes? Okay, how do we handle those? So we talked about those different sections in your books. I'm going to give you examples of each one that will be on the test here, so that you know what to study for. So let's take a look at this. Okay, again, this is simplification of radicals. Okay, the first one on here, this is number 12. Is pretty simple. We're just adding and subtracting. Again, these are not the exact ones that are on the test. They're just ones that I've either made up or found examples of in the book. Okay, so we have -2, excuse me, -2 in the square root of 3, -5 in the square root of 3, plus the square root of 12. Okay, so this is one that's similar to number 12 on the test. Okay, so what do we do here? Well, we know that we can only add or subtract radicals with the same radicand. Okay, so here and here, these two share the same radicand. Okay, and we understand that. So we could combine those two together, but I've got this radical here that does not. So my question is, can I break this radicand down so that one of the factors of this is 3? Well, what are some factors of 12? We've got 4 and 3. So 4 has a square root we could take out, and 3 would then remain inside. So I would rewrite this as -2, the square root of 3 minus 5 and the square root of 3 plus the square root of 4 and 3, because 4 times 3 is 12. Okay, then I would rationalize this. So we've got 2 in the square root of 3 minus 5 in the square root of 3 plus the square root of 4 is 2, so that comes out, and 3 remains in. Now that they all have the same radicand, I can then add these terms that are outside of my radicand. So -2 plus a -5 plus a +2. Okay, so that would give me 5, 6, 7 minus 2 positives would give me a negative, let's see, 5 and the square root of 3. And that's my answer. Okay, so number 12 is similar to this setup here. Remember, we can only add and subtract radicals that have the same radicand. Okay, so if we can break down those radicals to all have the same radicand, then we want to do that so that we can add them all together. If not, if I could not break this number down right here, I would basically just combine these two and leave this in its radical sign, okay? But because we could break it down, we break it down, and then we can add them all together and get one answer here, okay? So that is similar to number 12. Let's look at number 13 then. Okay, and I hope that you're writing notes on all of this so that you have it to know what to study for the test, okay? Now we have one where we're dealing with fractions that are in a radical sign, okay? Now remember, when we're talking fractions in a radical sign, we know that we cannot have a radical sign in our denominator, okay? So what we're going to do with this is we're going to split these up so that our numerator and our denominator are in separate radical signs, okay? And then in order to rationalize the denominator, what we're going to do is multiply this by, let's see, y cubed and y cubed. Okay, by doing that, this is going to remove this radical sign. Okay, so I'm going to get and I just saw something that I may have to go back and undo. And y cubed. Okay, now looking at this here, okay, we've got, we multiply these together. Remember, we can multiply different radicals together. Let me just check this quiz here for a minute. Y and, yeah. Okay, so we can rationalize the denominator by multiplying it by the denominator over the denominator, and that removes our radical sign. Now, here's the thing. We need to look at our factors for each of these variables and see if it can be broken down. Remember, if I still have numbers in my radical sign that can be rationalized further, then I need to do that, okay? So I'm talking about square here. My x I can't do anything because there's only one, but I can break down my y cubed, okay? So what does that look like then? So that looks like x times y squared times y, right? Because we have 3 y's. Break them down so that this one will rationalize and this one will remain in, okay? And then my y cubed is still at the bottom. Okay, so by doing that, this gets square rooted out. So I've got y, x and y over y cubed. Okay, now this and this can reduce. So y, leaving me with y squared. So I have the square root of x times y over y squared. Okay, now looking at my radical, nothing else can be factored out further, okay, or radicalized. So this is as far down as we can take it. And then we've canceled out, so our y, we have x times, the square root of x times y over y squared. Okay, so let's walk back through this again so we're not confused here. We started off with x over y cubed. Okay, we broke those up into their own radicals. Okay, and then we multiplied this fraction by y cubed over y cubed. We did that so that this radical sign would be eliminated. Okay, so by multiplying y cubed by y cubed, we get y cubed rationalized outside of our radical sign. Okay, and then we multiplied y times y cubed, so we get the square root of y, or square root of x times y cubed over y cubed. Now the problem is, the reason why we can't stay here is, just like a number, this variable can be broken down further, one that has a perfect square root and one that does not. So we can't just stop here. We have to break this down further. So here's where we break it down. We had our x, we can't do anything with that. We can't break that down any further. But we take our y cubed and we break it down so we have one square and one y. Now y squared, why do we have a squared here instead of just leaving it cubed? Well, what's my index here? My index is 2. Okay, so I'm looking for sets of 2 that I can break this y down into. So I have one set of 2 here. So we took y out of the radical sign, the y square. One set of y squares comes out, and then our y remains in, leaving us with y, the square root of x times y over y cubed. And then just like any other fraction, we reduce. So this y cancels out one of these y's, leaving us with y squared. And this is our answer. Okay, so the point here that we need to remember is, if we can break down our numbers to be factored out further, then we need to do that. Okay, so before you put your answer down on paper, make sure that you have factored that out as far as you can. There's no other exponents that can be broken down in order to get that to its lowest possible form, okay, before you put your answer down on paper. All right, so that was number 13 on the test. Let's look at number 14. Okay, number 14, we have an example similar to this. We've got 3 plus 2 and the square root of 5 squared. Okay, now anytime we have this, what this means is we're basically multiplying 3 plus 2 in the square root of 5 times 3 plus 2 in the square root of 5. Okay, meaning this is a perfect square, but if we're going to multiply it out, we're going to expand it so we can see what we're multiplying. Okay, so we're simply just multiplying these two equations together, these two binomials together, using the FOIL process. Okay, so we multiply 3 times 3, which gives us 9, and then we multiply 3 times 2 and the square root of 5, okay, which gives us 3 times 2 is 6, so we have 6 in the square root of 5. And then we have the same thing here, 2 in the square root of 5 times 3, which is 6 in the square root of 5. And then we've got 2 in the square root of 5 times 2 in the square root of 5. So what this looks like is 2 times 2, those are our 2's, and then the square root of 5 times the square root of 5. What happens when we multiply the square root of 5 times the square root of 5? That gives us 5, okay? So I'm basically multiplying the two numbers that are outside together, giving me 4, and then 4 times 5, which is 20. Okay, so here I've got 9 plus 6 in the square root of 5 plus 6 in the square root of 5 plus 20. Okay, so we're just going through this process of foiling, okay, to get our numbers. Remember, when we multiply, the numbers inside the radical sign just stays. We don't touch that, okay? But the numbers outside the radical signs get multiplied. And then when we multiply the same radical by the same radical, it basically just drops the radical sign, giving us just whatever that number is inside, okay? And then here we just multiplied the product of 2 times 2 with 5 to get our last term there. Okay, so from here, what I have to do is then combine my like terms. These are like terms, right? They both have the square root of 5. So 6 plus 6 is... I'm just looking at my notes here. Sorry, guys. I thought I had skipped a step, but I didn't. Okay, 6 plus 6 is 12, and the square root of 5, because that doesn't change when we're adding. And then we've got 9 and 20. Okay, so 9 and 20 is 29. All right, so my answer then is 29 plus 12 and the square root of 5. Okay, so that's how that breaks down there to work. So we've got this perfect square binomial. We expand it, we FOIL, okay, and we get our all of our terms here, and then we combine our like terms to get our answer, okay? And that is similar to number 14 on the test. Let's look at number 15. Number 15 is something like this. We've got 5, 3 minus the square root of 2. Okay, now, the problem with this here is we have a radical in our denominator. Now, the difference between this radical in our denominator and the other one is because this is a two-term denominator, we can't multiply this by 3 minus the square root of 2. We have to multiply it by its conjugate. Okay, now remember the conjugate is the opposite sign. So we have 3 plus the square root of 2 over 3 plus the square root of 2. So here is the difference between just simply rationalizing the denominator and trying to rationalize a two-term denominator. With the two terms, we have to multiply by the conjugate of the denominator. Okay, so don't forget that as we're going through here. Okay, so All we're doing here then is multiplying 5 times 3, which is 15, and then 5 times the square root of 2, which is 5, and the square root of 2, okay? And then we've got 3 times 3, which is 9, and then a negative square root of 2. Remember, we got a square root of 2 and a square root of 2, so that comes out, okay? And because one is positive and one is negative, we have a negative 2, okay? And then you just combine your like terms. These can't be combined because this has a radical and this does not. So this remains as 15 plus 5 and the square root of 2 over 9 minus 2, which is 7, okay? And this then is my answer for this problem. So remember, when we're rationalizing a denominator that it has 2 terms, okay, we have to multiply it by the conjugate, okay, and then you just simply multiply each term by each term to get your answer, okay. So that is number 15. Let's look at 16 here. Okay, 16 is, what if I have something like this? Okay, what do I do here? Now remember, I have to have the same index in order to multiply these. So how do I get the same index for both of these in order to multiply them? When I have a situation like this, I have to turn these into fractional exponents, okay? So I've got x. My denominator is always my index, okay? So I've got 4, and then my exponent is my numerator, times x and 1/2. Okay, so we turn these into fractional exponents. Now this is the same thing as this, and this is the same thing as this. It's just written in a different form. Okay, so I haven't changed anything. I've just rewritten them in a different form. Okay, now I want to add these two together. So I want to say x 3 over 4 plus 1/2. The problem is when I'm adding fractions, what do I have to have? It has to have a common denominator. So I have to turn this fraction into a fraction that has a 4 as my denominator. And we do this the same way as if I had 3 over 4 and 1/2. What would I multiply it by to get this to be a fourth? I would multiply it by 2, okay? So that I would get 3 over 4 plus, let's see, it would be 2 over 4, okay? Now I can add these together, okay? So I just simply multiplied this by 2 so that I can get something that has the same denominator there, okay? So now I can add these two fractions together, okay? By doing that, I get x and 5 over 4, okay? Once I've combined them together, now I can put them back into my radical. Remember, my denominator is my index, and my numerator is my the exponent of my radicand. Okay, now typically this would be my answer, but as is always the case, we want to break it down into its lowest form. So can I break this down into sets of 4? Well, I know I have at least one set of 4 hidden within this x to the 5th, okay? So I'm going to break this down even further, and I'm going to say this, x to the 4th and x1. Now together, this is this, okay? I've just broken this down so that I have one set of 4 so that I can rationalize this and get this out of the radicand, okay? So I look at this and I say, how many sets of 4 do I have? I only have one set of 4, so I have one x on the outside, okay? And this remains a 4 here, excuse me. And then whatever's left over, which is my 1x, stays on the inside, okay? So my answer is x times the 4th root of x. And that would be my answer there. So once you get to this spot, you've put them into fractions, you've added them together, you put them back into the radical. Make sure that you break this number down into sets of whatever your index is, okay? If there are no full sets of your index, then you just leave it and this is your answer. But because I have at least one set of 4s in this x to the 5, I have to pull that out, okay? Because I want this to be in its simplest form here. Okay, hopefully that wasn't too confusing for you. We're going to stop there, I think, for today because I don't want to give you too much information. That's going to be your first part of your test that we will be taking on Wednesday. Or excuse me, today's Wednesday. On Friday. Okay, and then we'll take the remainder of it on Monday. Unless you'd like to take it all together, then you're welcome to. But I don't want to overload you too much here. So that'll be your first section of your tests, okay? And again, this is your 9-week or a quarter exam, okay, 9-week exam. So this covers chapters 7 through 9, okay? We're going to do this first part on Friday, I believe. Let me double check what my notes say here. Hold on just a second. So on Friday will be part 1 of that test number 9, okay? So just to review, you've got your 3 multiple choice, know what a pure quadratic equation is, know what your quadratic formula is, and then know how to find a perfect square from a trinomial, okay? And understand what that means. And then 4 through 7 is the different forms of factoring. And then 8 through 11 are modified true and false. So make sure you go back and determine whether it's true or what the proper answer would be if it's false. And then you've got your simplification of radicals on numbers 12 through 16. Okay, so for today's homework, what we're going to do is I want you to go back into your factoring section, okay? And I want you to practice your factoring section, okay? In fact, let's look at our book here. Go ahead and open your book. I'm going to have you do this section here for your review, which would be a good help for your test. So for your homework tonight, we're going to practice this factoring and the radical section of this test, okay? So turn to page number 336. At the bottom of 336 there, you'll see this review of factoring and radicals, okay? Review of factoring and radicals. So this is the section that I'd like you to do for your homework today, all right? So let me give you the exact numbers because there's a lot on here and you don't need to do all of these. I want you to do 3, 5, 4, 6. And then I want you to do 13, 15, 19, 21, and 25. And then, let's see, 29 through 32 is solve each radical equation. So yeah, I want you to do numbers 29 and number 30. And then, let's see, find the distance between the two of each pairs. I don't need you to do that. So we'll stop there at 30. Okay, so your homework is 3, 5, 4, 6, 13, 15, 19, 21, 25, 29, and 30. Okay, so that's 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So that will be your homework for tonight. Okay, and that will give you a good review for the factoring and the radical section of that test. All right. So that's all I have for you today. Again, your homework 3, 5, 4, 6, 13, 15, 19, 21, 25, 29, and 30. Okay, so that is that. You know what? Let's skip number 21. Okay, you don't have to do number 21. We'll take that one off. Okay, that'll give you 10 questions. So 3, 5, 4, 6, 13, 15, 19, 25, 29, and 30. All right. If you got any questions on that, give me a call, get a hold of me, let me know, and we'll make sure that we're ready to go for that test, the first part of your test that we'll take on Friday. All right, that's all I have for you today, and we'll talk to you later. Bye-bye.